A new study published in PNAS highlights a newly identified mechanism of how auditory sensitivity is regulated that could temporarily reduce sensitivity of the auditory system to protect itself from loud sounds that can cause irreversible damage. The study, led by CU Anschutz researchers Andrew Mecca and Giusi Caprara in the laboratory of Anthony Pung, tested a decades-old hypothesis which proposed that the gating spring, a tiny, nanometer-scale protein structure which mechanically opens and closes an ion channel in sensory hair cell's eye. Previous work in the auditory field has focused mostly on understanding mechanisms which target the ion channel. This study provides the first evidence that the gating spring itself has the capacity to modulate the sensitivity of the channel. This study documents the first time we understand a mechanism that regulates auditory sensitivity on both the molecular and mechanical levels, says Pung, Ph.D., associate professor at the University of Colorado School of Medicine and senior author of the study. We uncovered a new mechanism of modulating sensitivity, which opens the door to discovering more about how the auditory system functions generally and uses this to both maximize the range of sounds that we can detect and protect the vital sensory cells from potential damage. The mechanism discuss. The researchers studied the properties of the gating spring and the resulting activity of the channel in single sensory hair cells, and found that cyclic adenosine monophosphate, CAMP, a specific type of signaling molecule, reduced the stiffness of the gating spring and decreased the channel sens. Identifying the underlying mechanism of this process, how it works physiologically and mechanically, provides an avenue for future research and provides an opportunity for the field to develop a new type of drug that can be used to prevent a type of hearing loss that occurs from exposure to very L. Ultimately, they aim to learn more about how the ear can detect such a large range of sounds and how the system protects itself, and this represents a huge step forward for the field. Make a difference. Sponsored opportunity StorySource. Materials provided by University of Colorado Anschutz Medical Campus. Original written by Kelsey Peters. Note: content may be edited for style and length. Journal reference: Andrew A. Mecca, Giusi A. Caprara, Anthony W. Pung. Camp and voltage modulate rat auditory mechano-transduction by decreasing the stiffness of gating springs. Proceedings of the National Academy of Sciences, 2022. 119, 30, doi. 10. 1073, PNAS. 21075671119. Cite this page. University of Colorado Anschutz Medical Campus. Researchers identify a new mechanism responsible for controlling auditory sensitivity. Science Daily, the 22nd of July 2022. ift.tt/vitkiak. University of Colorado Anschutz Medical Campus. 2022, July 22. Researchers identify a new mechanism responsible for controlling auditory sensitivity. https://ift.tt/vitqyaq. Access July 22, 2022. Thanks for watching. Please subscribe my channel for more videos.